Okay, in previous class, we have discussed. So we thought that what are the advantages and why we need the inception and ResNet networks for the image classification tasks. And so inception create to serve a purpose of reducing computational burden in deep neural networks as well as the residual networks which are used to avoid overfitting by using the skip connections, or we can call it as a residual connections presented in the network. And in this we'll discuss about uh, inception, so we'll discuss about MobileNet. So in MobileNet, as the name says that this model is designed to use in the mobile applications, and which is a first mobile model in the computer vision. So that is used for the image classification, image recognition, and in any other applications. The mobile net uses depth-wise separable convolutions, and it significantly reduces the number of parameters, and it results in the lightweight deep neural networks. So due to the less number of parameters, it reduces the computational complexity. So this is, we can see that the structure of your mobile net. So this is your input. The input of MobileNet is 220 cross 220 cross into 3. Then we can go. It will go for the convolutions. So and so so so. So see here, the size is also reducing. So size is at the end of that your last layer. So the size is 7 cross 7. So but we are introduced into 227 into 227 as an input. So this is with the use of this depth-wise convolution and point-wise convolutions, so the computational complexity will be reduced in the mobile net, so it make it as a lightweight. And so what is mean by depth-wise separable convolution, as well as what is mean by point-wise convolution. So this is, here we can see that a depth-wise convolution diagram. So here we can see, so this is a basic input. So this input is divided into d cross dk. So dk cross dk convolution. So here this block is of dk and this is block of dk, then we convoluted, so then again we will get it this convolution block. So after this, so we can convolution blockwise, so point wise, so we can consider here a point to point convolution here. So this is how it works. So this depth-wise separable convolution is made from two operations, that is depth-wise convolution and point-wise convolutions. So this is an open source network, which is you can usually use it for classification and training of any image data set, signal data sets. So this is how the depth-wise separable convolution is works. So already I said that this is divided into dk parts. Then this dk dimensional parts is, that is the depth-wise convolution, that will be convoluted same with the same number of layers, that is the same number of kernels. Then it will be convoluted, then we will get it output like this. So this is same as you mentioned in the previous. Then this will converted into 1 cross 1. So here dk is any number, but it will convert into pointwise, so means you can convert into one point to point. This helps in the classification, so precise classification of any images, and it may give good efficiency also. And here, so it is there is depth-wise convolution is the channel-wise dk spatial convolution. Suppose in figure, so we can see the 5 channels, then we have 5 different see here 5 different dk are there. So here we are seeing that 5 different channels, right? And then we have converted that into 1 cross 1. So this is 1 cross 1 convolution here. Then so depth-wise conversion is like this. So dk into dk, then we'll convert it into 1. Okay. And in this mobile architecture, the main layers are like batch normalization, convolution, that is depth-wise layer. This is relay activation. So these are the main important layers. So here it is in figure A showing that a standard convolution layer with batch normalization and relay. And figure B shows that a depth-wise separable convolution and point layers followed by the batch layers. So see, this is a regular network and this is a mobile net architecture where, so in regular network we have only convolution layers, but coming to the mobile net, so it has a depth-wise, then that depth-wise convolution is converted into 1x1 point convolutions. So this is how we can make it mobile net as an lightweight network. So here we can use this MobileNet. In MobileNet we can use this object detection. So now I am facing a camera, right? So using that camera, so we can detect my face. So that is also one of the classification, one of the advantage of that. That is we can call it as object detection and face attributes. So now I am facing to the camera, so it can detect. So we can give the data sets and we can train first. Then it can detect our face with respect to our face. It will detect who am I, and whether I am wearing face mask or not. So this different again we have to give some other image data sets and you have to train with respect to that. And this is the mobile network, and this is how we can classify. This is like whether the different types of animals, and this is where landmark recognition, and in many networks it can be used. And the main advantages of this is the speed and power consumption of the network is proportional to the number of max, which is measurable of number of fused multiplication and additional operations. So we can calculate the number of what is the speed of the network and what are the power consumption of the network from the MAC addresses, which is measured by number of fusion multiplications. So like in convolutions, here we can see the number of multiplications, right? So with respect to that, also we can find it out the speed and power of the particular network. So this is, and for example, so with the mobile net, so we have the image classification example. So that has been given in this website. You can go and check it out. That is Analytics Vidya. In that, so they have used, I think, Cipher 10 or MNSIT data. So they have used it for the classification using they have done the image classification with respect using the mobile net. So this is what we can. So already in the previous classes you come to know why we need these three networks with respect to do the image classification, and how this will be works, that is inception and result with similar way. So the layers will be similar, but one thing is instead of regular convolution, so here it is depth wise convolution layers we will use. Okay, thank you.